Hello everyone, I am here to discuss the chemistry MCQ paper prepared by Gampaha Medical Students Association for 2025 students. If you haven't done the paper, please do it and come again to watch the recording. Let's go to the first question. Consider the following statements. Okay, so it says the scientists that put forward the statements 1, 2 and 3 respectively. So let's read the first statement. The atoms of each element have a characteristic number of protons. Other word we can say atomic number. Atomic number was discovered by Moseley, and he also have been discovered the prediction of some missing elements and the redefinition of the periodic table. So you don't want to see other two statements. If you see directly, you can see the third answer, it is the Moseley, because that is the only scientist that is given as Moseley for the first statement. So the answer is third, but you can see the other two statements also. The second statement, the radiant from a metal surface behaves like a stream of tiny energy packets, which is directly said by Albert Einstein. And the other side of it, which is electrons have nature, like electrons have wave nature, is given by Louis de Broglie. So the second statement, the scientist is Albert Einstein. Let's see the third statement. The nature of cathode rays remains the same regardless of the material of the cathode or the gas taken in the discharge tube, which is known as the charge over mass ratio of electrons. Charge over mass ratio of electrons is not changing, which is discovered by J.J. Thomson. So the answer is third one for the first question. Let's go to the second question. Which of the following statements regarding a given electron of an atom is false? So they are asking the false statement. The first answer, spin quantum number is the quantum number that exists as a fraction, correct? Because we can have like plus half or minus half. That can be the spin quantum number. So the second answer, the azimuthal quantum number defines the orientation of the orbital in the space. That's totally wrong, because azimuthal quantum number defines the shape. If it is S or P sub energy level, we can find the shape, but orientation of the orbital is given by the magnetic quantum number. So the third, so we can see the second answer is wrong. So I'm guessing the second answer is the incorrect statement. Let's see the others too. Third one, when the principal quantum number increases, the orbital becomes larger. That is correct, because principal quantum number is the main energy level. When main energy level increasing, the size of the orbital also increasing. So you can see like this is the first energy level, second energy level, third energy level. S orbitals, the size of it is increasing. Fourth one, the magnetic quantum number can have positive and negative integrals values including 0. That's correct, because if you consider the p orbital, we have the L value for p orbital is 1. So if you consider the magnetic quantum number for the p orbital, it is -1 or 0 or +1. So it is continuing like that. So therefore it can be positive, negative, also 0. Fifth statement, the angular momentum quantum number defines the shape of the orbital. That is correct. Angular momentum quantum number is the azimuthal quantum number. As I said before, it defines the shape of the orbital. Therefore, answer of the second question is 2. Let's go to the third question. The mass of an electron is 9.1 into 10 to the power minus 31 kilogram, and its velocity is 5.9 into 10 to the power 6 ms minus 1. Based on the wave nature of the electron, the de Broglie wavelength is, they have given the Planck constant, so we can directly do the question with the equation. De Broglie wavelength is equals to Planck constant divided by mass into velocity. So de Broglie wavelength is equals to, the Planck constant is 6.63 into 10 to the power minus 34 joules per second divided by mass 9.1 into 10 to the power minus 31 kg into velocity 5.9 10 to the power 6 ms minus 1. So you can cancel the power values, and if 10 to the power 6 comes up, you will get an answer 0.12 into 10 to the power minus 9 meters. Here, if we take a 1 decimal place backward, you can say 1.2 into 10 to the power minus 10 meters. Therefore, the answer is the second one, which is 1.2 into 10 to the power minus 10. Let's go to the fourth question. The shapes around the central atom I3 minus, BrO3 minus and IO4 minus are respectively. So we can just draw the shapes and we can find it. So if we consider the I3 minus, the Lewis structure is here you can see the shape is the linear. And if we see the BrO3 minus, shape is the trigonal pyramidal. And if you consider the IO4 minus, it is tetrahedral. So the answer is fourth one. If you find the first two molecules, the shape of the first two molecules, directly you can find the answer is fourth one. So I have drawn the third one too. Let's see the fifth question. What is the IUPAC name of the following compound? So I will draw the compound. So this is the compound. As you can see, the main group is the carboxylic acid group. Therefore, this compound should be an acid. And if we find the longest possible chain of the carbon, including the double bond, we can mark from here 1, because this is the main group, 2, 3, 4, 5. So there is a there is a bromine attached to the 5th carbon, and there is a formyl group attached to the 2nd carbon. So we can write the name, IUPAC name. As we are writing the IUPAC name, we have to write according to the alphabetical order. So bromo, which is the B, so it comes front. We can write as 5 bromo. We have to put a dash between a number and a letter. Bromo. And a formyl group is attached to the 2nd carbon. So 2 formyl. And then you can see, then we have to mention the double bond, which is the alkene group. So you can mention the lowest number of the carbon, which is 3, and carbon chain, there are 5 carbon, therefore it is a pentene chain. So pentenoic acid. So this is the IUPAC name of this chain. So you have to mainly consider that the IUPAC name is written according to the alphabetical order, and also you have to consider the group name and which is the main group. If you can find those, you can easily find the answer for this question. Let's move on to the 6th question. Sixth question is a calculation one. Let's see. At 298 Kelvin, the maximum amount of calcium nitrate solid that can dissolve without forming any precipitation in 1 decimeter cubic of an aqueous solution with a pH value 30 is 1.06 gram. The solubility product of the calcium hydroxide can be. So if we can clearly find the answer, if we can clearly separately see the question, you can easily get the answer with a methodical way. First of all, let's find the calcium nitrate molar mass. Calcium nitrate molar mass, we can find like 40 plus 14 plus 48 multiplied by 2, which is the 164. You can find that. Then later you can see they have given the pH value. So from the pH value, you can find the hydroxyl concentration in the solution. So with that, you can find the, after that you can find the calcium concentration, calcium 2 plus concentration in the solution from calcium nitrate which have been dissolved earlier. So both together, you can find the solubility product of calcium hydroxide. So you can see solubility product of calcium hydroxide is calcium 2 plus aqueous OH minus aqueous. Yeah. Because if you write the equation, even you can understand that. As there is 2 in front of hydroxide, it becomes the power in the KSP, which is the solubility product. Let's see the concentration of calcium 2 plus in the solution. So we can find the concentration of calcium 2 plus in the solution if we can find the mass. So if we can find the number of moles. So if we consider the number of moles of calcium nitrate, I will directly put as calcium 2 plus, because if calcium nitrate have 1 mole, calcium also have 1 mole, the same mole number is equals to mass over molar mass. Mass 1.06 gram divided by molar mass, we have found 164 gram per mole. So we will get an answer as 6.46 into 10 to the power minus 3 mole. You can just round off the answer 6.5, because when you are seeing the question, you can see if you round off this answer, you can easily get it. Now let's see the hydroxide concentration in this solution. They have given the pH value. pH value is 13. So pOH value is 14 minus 13. Therefore, pOH is equals to 1, which is, I will just write it if you want, equals to 1. So now you can find the hydroxide concentration using pOH is equals to minus log HO minus aqueous. So pOH, we know the pOH, which is 1, is equals to minus log OH minus aqueous. Therefore, OH minus concentration is 10 to the power minus 1 moles per decimeter cubic. Here we have found the mole. As they have said, the solution volume is 1 decimeter cubic. You can divide this by 1 decimeter cubic, and the concentration of calcium 2 plus can be taken as 6.5 into 10 to the power minus 3 moles per decimeter cubic. So here we can substitute these values to this equation. So calcium 2 plus concentration is given into 10 to the power minus 3 moles per decimeter cubic. So if you multiply this by 10 to the power minus 1 moles per decimeter cubic square, so you will get an answer as 6.5 into 10 to the power minus 5 moles per decimeter cubic. So that is the answer, which is the third one. Let's see the seventh question. Choose the answer shows the incorrect variation of the given factor. Okay, let's see the statements, the answers. First one, atomic radius increases from HFSR potassium. That is correct, because first you can see hydrogen, which is first orbital. For sure, fluorine have a greater radius than hydrogen. That is correct. And sulfur, which is the second period. This is first period and second period, and this is third period. So as the number of energy levels are increasing, their radius have to be increased. So H is greater than sulfur. This part is correct. But when you consider the strontium and potassium, potassium is in the fourth period, but strontium is in the fifth period. So as you're thinking, like when the energy level is increasing, the radius have to be increased, but that's wrong. There are some exceptional cases, mainly in this potassium and strontium. Here, potassium have a greater radius than strontium. Same like that, you can say some examples as rubidium have greater radius than barium, and also sodium have greater radius than gallium. These can be given as some examples, which are some exceptions. So according to this exception, the first statement is correct. So this statement is a really good question. They are just mentioning a nice key point. So let's go to the second one, electronegativity. Electronegativity, it is better if you can memorize the table of the values. There is a pattern to memorize. If you can memorize, that is better. So I will just write the values. Sodium have 0.9, beryllium have 1.5, silicon have 1.8, boron 2.0, and sulfur 2.5. So you can clearly see, according to the order, electronegativity is increasing, therefore the second statement is correct. Let's move on to the third statement. If you consider the third statement, it says that the second ionization energy increasing order is given as this. We can just draw the pattern of the ionization energy. It just increases like this. So there is an element here and here. So normally hydrogen, helium, lithium, beryllium, like that it is increasing. We can just take a step forward, because normally beryllium should come this place, but as this is second ionization energy, one element will come forward. So beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So from the lowest point, if you increased, beryllium have the lowest, then carbon, beryllium have the lowest, then carbon have the, and then if you increase, there is no boron or nitrogen in this list. So if you increase, next one is fluorine and then oxygen. But they have given as fluorine and oxygen, they have interchange. Actually, fluorine have less second ionization energy than the oxygen. So then later you can say helium, because helium will come in this place. Here. So the third question, like third answer is wrong. Therefore, you can take the answer, which is the third one. You can directly get that answer now, but we will see the other two ones too. Let's see, fourth one, ionic radius. So ionic radius, when you're considering beryllium 2 plus and aluminium 3 plus, so they are saying ionic radius of aluminium 3 plus is greater than beryllium 2 plus, but it is 3 plus and beryllium is 2 plus. When you're considering that part, you may confuse as when plus nature is increasing, radius should be decreased, right? But here beryllium is in the second period, but aluminium is in the third period. Therefore, the energy level of the aluminium is greater. So aluminium have a greater energy level, greater radius than the beryllium. And if you consider the oxygen, as it has a negative charge, its ionic radius is greater than the aluminium 3 plus, and it is greater in nitrogen 3 minus because it has a greater negative charge. So if you consider S2 minus, which is in the next period, so one extra energy level is there. Therefore, S2 minus also have a greater ionic radius compared to others. And if you consider the fifth one, electron gain enthalpy, so this is the order. You have to memorize the order, and you can simply guess as the highest electron gain enthalpy is for the chlorine, and the second one is fluorine, and then bromine. Then you can go for sulfur and then oxygen. So like that only electron gain energy, electron gain enthalpy decreases. So for the seventh one, the answer is third. Let's move on to the eighth question. Let's move on to the eighth one. So they are asking, select the answer with the largest dipole moment among the given molecule. So the largest dipole moment means the electronegativity difference should be a greater one. So let's see. The first molecule, here when you consider the electronegativity of hydrogen is 2.1 and the carbon is 2.5. So carbon 2.5, therefore no any dipole moment for this bond, but there is a dipole moment for this one from hydrogen to carbon. So there is a dipole moment. So that is the dipole moment of this molecule. Let's go to the second one. You can see this one is kind of the pattern one, like the dipole moment of created by this bromine molecule, bromine atom can be cancelled by this one. Therefore, you can say the dipole moment of this molecule is 0. You can even see it, 2.5, 2.5 and 4.0, 4.0, 2.5. So the dipole moment created according to this one can be cancelled. Same that can be happened in the bromine. So if you go to the third one, so 2.8 is the electronegativity of the bromine, and 2.5 here, and 3.0. So there is a dipole moment over this direction, and there is a dipole moment over this direction, and there is a dipole moment over this direction and this direction. So if you consider the resultant, there is a resultant dipole moment to the downward and upward. So there will be a smaller dipole moment to the upward. So that is kind of the resultant. So let's see the fourth one. So the dipole moment here upward and here also upward. If you consider this molecule, so the dipole moment is upward for these chlorine atoms, and the dipole moment for the hydrogen also upward. So the resultant of this one is also upward. The resultant of the chlorine atoms also upward. So there will be a greater dipole resultant for the upward. So if you consider, definitely fourth molecule have a greater dipole moment compared to the third one, and the fifth one also have a zero dipole moment because all sides are chlorine. Same like this, you can cancel out. So therefore the answer for the 8th question is fourth one. Ninth question, the correct increasing order of the acidic strength of the following compounds is. So if you consider the acidic strength, you don't want to see, you can just directly find the greatest acidic strength is for the carboxylic acid. So which one is the answer? Directly you can get the third answer. Because carboxylic acid have the greatest acidic strength, and B is greater for third one only. You don't want to see others. If you want, you can even see the lowest acidic strength is for the amine, and the second lowest one is for hydroxyl group attached to benzene, and then third lowest is for carboxylic group attached to benzene, and other one is carboxylic acid. So which is the third answer? So you can directly find the answer using these methods. No need calculations, no need any steps to write. Let's move on to the 10th question. Answer for the 9th question. A gas converts to B gas and C gas is an elementary reaction. Rate constant at the given temperature is K. At the beginning, T equals 0 if the initial pressure is P1, and after a time period T, if the number of the system, if the pressure of the system becomes P2, which of the following expressions correctly represent the rate of the above reaction? So if you draw the reaction, A gas converts to B gas and C gas. When the time is equals to 0, the partial pressure of A is P1, and when the time becomes equals to a value of T, then the partial pressure of the system is P2. That means there have been a reduction of the concentration of A gas to form B gas and C gas. As P equals CRT, if there is a reduction in concentration, there is a reduction in pressure too. So if you consider the partial pressure of PA at the second situation, if you consider the partial pressure of PA, it is P1 minus X, because the before only A gas is found in the system, later only B gas and C gas are formed. Initially as A gas is found, the pressure of the A gas is P1. So if you consider the partial pressure of A gas in the second situation, there is a reduction in the initial pressure to return to its position of partial pressure PA. So there is a reduction of partial pressure. I have mentioned that as X. So P1 minus X. This partial pressure reduction have been increased in the B gas and C gas. So partial pressure of B gas is X, also partial pressure of C gas is also X. So if you consider pressure total is the P2 is equals to partial pressure of A plus partial pressure of B plus partial pressure of C. So P2 is equals to P1 minus X plus X plus X, which means equals to P2 minus P1 becomes equals to X. So we have found the reduction of partial pressure. This is the reduction of partial pressure in the P1, in the partial pressure of A gas. So if we substitute this one to this place for the X, you can find the partial pressure of A gas, because they are asking the which of the following expression correctly represent the rate of the reaction, right? So if you consider the rate of the reaction is equals to rate constant into the concentration of the reactant. As this is an elementary reaction, this is a first order reaction, therefore you can represent this concentration for this position, and you can find a proportional value. So if you consider the partial pressure A, as we can substitute this one, P1 minus P2 minus P1, so 2P1 minus P2. So this is the partial pressure. As you know, PV equals nRT, which is P equals CRT. Partial pressure, the pressure is proportional to the concentration. So you can represent this value here as you can as taking the rate is proportional to 2P1 minus P2. So no need for the calculations, you can directly get as proportional because they are asking the proportional answer, right? So the answer is the third one for the 10th question. Let's see the 11th question. From a sample containing sodium carbonate and magnesium carbonate, only 27.4 gram of it was subjected to thermal decomposition. Then 0.2 gas moles were emitted. What is the percentage of the sodium carbonate in the sample? For doing this question, you should know a theory statement, which is sodium carbonate is a stable compound. It is a stable lattice compound because magnesium carbonate can be decomposed at a temperature around 350 degrees Celsius to 540 degrees Celsius. But in laboratory systems, sodium carbonate cannot be decomposed. Therefore, in this question, sodium carbonate remains same and it doesn't decompose, only magnesium carbonate decomposes. So if magnesium carbonate decomposes, you can have magnesium oxide and carbon dioxide, which is a gas. So if you consider the released mole of gas is 0.2 moles. As the mole value for magnesium carbonate, mole ratio for magnesium carbonate and carbon dioxide is 1:1. The number of mole present in the solution is also 0.2 mole. So you can find the mass of the magnesium carbonate. magnesium carbonate is equals to, so number of mole is 0.2 moles, and the molar mass of the magnesium carbonate is 84 grams per mole. You can find that. I didn't spend time to find it. Okay. So, into molar mass, 84 gram per mole. So, you can have a mass of 16.8 grams. So, if you subtract 16.8 grams from 27.4 grams, you will get the mass of sodium carbonate, which is 10.6 grams. So now you can find the mass percentage as the 10.6 gram divided by total mass 27.4 grams into 100%. Mass percentage, we can find the mass of the substance divided by the total mass into the 100%. So if you did this calculation, you can get an answer as 38.68%, which is the third answer. So answer for the 11th question is third. Now let's consider the 12th question. Consider the following thermochemical data given in kilojoule per mole. Lattice enthalpy of silver iodide and hydrogen enthalpy of silver and standard hydrogen enthalpy of iodide. According to the equation is there. Which of the following is the standard enthalpy of dissolution? So the equation represents the standard enthalpy of dissolution. Plus H2O forms aqueous. So this is the standard enthalpy of dissolution. You can just mark as H0 dissolution. So if you draw a thermochemical cycle, you can easily find the enthalpy of dissolution using the Hess's law. So we can have, there are three, they have given three values. First, we can use the lattice enthalpy because this one is solid. You can't move on to the next step without changing this one. So the enthalpy given is lattice enthalpy, which is the lattice formation enthalpy. But if you draw the arrow in this direction, it means the lattice dissociation enthalpy. If the lattice dissociation enthalpy is given, the value should be plus I minus plus H2O, and it is a plus value. Okay. So when you convert like the next one, hydration enthalpy of Ag plus and the hydration enthalpy of I minus. So here Ag plus gas is there and I minus gas is there, water is there. So I'm going to write both together. So the hydration of both will be in results aqueous plus I minus aqueous. So the values will be minus 464 minus 293. And then this can be represented as Ag together even. So if you write down according to the Hess's law, you can say H0 dissolution is equals to plus 876 minus 293. So you will get an answer kilojoule per mole. So which is the second one. I haven't written the units for these values, but when you are writing an essay, you have to definitely write the units in each and every term. So as this is an MCQ, I didn't write that. So let's move on to the 13th question. 13th question, you know, it is an easy one. You don't want to do any calculations. You can just take it easily. The solubility constant of a weak base MOH in an aqueous solution at 25 degrees Celsius is 1 into 10 to the power minus 5 moles per decimeter cubic. Following solutions are made by mixing 10 centimeter cubic of 0.02 moles per decimeter cubic concentration of MOH. So the first, there are 3 steps and like 3 separate solutions. So they are asking which of the following gives the M plus ion concentration at 25 degrees Celsius. So the increasing order or the decreasing order. If you consider the first one, they have added the X solution 10 centimeter cubic with H2O 10 centimeter cubic. That is the P. Kind of same to the 0.02 moles per cubic decimeter of 10 centimeter cubic of the HCl. That is the Q. And the NaOH of the same concentration and the same value is the R. So we know the solubility product is this is the solubility product for the MOH weak base. So you have to consider solubility product, which is the KSP, only depends on the temperature. So when temperature changes, only this constant will be changed. According to this question, they are asking at 25 degrees Celsius. That means temperature is constant. So if you consider when hydroxyl, that means OH minus ions increased, definitely M plus ions in the solution should be decreased to balance the KSP. So according to that concept, if you consider the Q, which have according to that concept, if you consider the sodium hydroxide solution, which have the highest OH minus ions, in this solution, they have highest OH minus ions. That means lowest M plus ions is for the R. Because when OH minus increases, M plus ions should be, concentration of M plus should be decreased to balance the KSP. And if you consider the HCl, in the HCl solution, OH minus concentration is the lowest. Therefore, when OH minus concentration becomes lowest, M plus ions should become greatest. Therefore, Q is the greatest concentration of M plus ions. Then the second, the P statement, which is dissolved with H2O, they have neutralized value of OH minus, so it can be come to the middle. So the answer is, they have written in the other side, so the answer is third one. You have to mainly consider that KSP value only changes with the temperature, regardless of the concentration of the reactants or the products. So let's move on to the 14th one. In the 14th question, which of the following mechanism is correct? You have to change it. Actually, the question should be which of the following mechanism is incorrect. So if you consider the first mechanism that is correct, it is in the resource book. So, and even the third, fourth and fifth mechanisms are correct. But when you consider the second mechanism, that is the wrong one. So for the 14th question, the answer is the second. Because when you consider the second mechanism, you can see it is a tertiary It is a tertiary carbocation because in the intermediate compound it forms a tertiary carbocation. So definitely this reaction should be happen in 2 steps, but they have given in 1 step. Also they haven't marked the release of chlorine from carbon. The chlorine Cl minus have to be released. That arrow is also missing. So definitely the incorrect mechanism is the second one. Other mechanisms are correct. So let's move on to the 15th question. It is a titration question. The mass of a sample containing only sodium bicarbonate and sodium carbonate is 9.72 grams. 2 aqueous solutions were made using it by allocating half of it for each solution by adding water. Methyl orange was added to the solution while phenolphthalein was added to the other and was titrated using 2 moles per decimeter cubic HCl. And the volume of HCl used was 40 centimeter cubic and 15 centimeter cubic respectively. Find the mass percentage of sodium bicarbonate in the sample. So they have prepared 2 solutions using both have sodium bicarbonate and sodium carbonate only. So if you consider the sodium bicarbonate moles as X and sodium carbonate moles as Y, this solution contains X over 2 and Y over 2 amounts, and this one also X over 2 and Y over 2 amounts. Also in here phenolphthalein is added and here methyl orange is added. So this one 15 centimeter cubic, the titrated volume for the HCl, and titrated volume for the HCl in this place is 40 centimeter cubic. According to the phenolphthalein indicator, only bicarbonates converts to NaCl, H2 and carbon dioxide, but carbonate ions doesn't change. So sodium carbonate will convert to sodium bicarbonate. Sodium carbonate reacts with HCl, sodium bicarbonate. So if you consider, they have given the volume and the concentration of the HCl which have been titrated with the sodium carbonate. So if you consider the number of moles of HCl, Cp, concentration of the HCl is 2 moles per decimeter cubic into the volume 15 into 10 to the power minus 3 decimeter cubic. So the answer is 0.03 mole. As the mole ratio for the HCl and sodium carbonate is 1:1, the reacted moles of sodium carbonate in this situation is 0.03 mole. As sodium carbonate is Y2, therefore the actual number of moles of the sodium carbonate in the main solution is the 2 times of this, which is 0.06 moles. So that is the reaction and equations that happens in the first solution. If you consider the second solution where methyl orange is added, with the methyl orange indicator, both the sodium bicarbonate and sodium carbonate are dissociates, will be titrated. So if you consider the sodium bicarbonate reacts with one HCl molecule to form and then sodium carbonate reacts with 2 HCl to form 2 NaCl plus H2O plus CO2. So if you consider, we know the number of sodium carbonate molecules in the main solution. In the main solution is 0.06 mole. So if you consider the Y2, which is the half of the sodium carbonate is present in this solution, then it is 0.03 mole. Therefore, the titrated HCl number of moles with the sodium carbonate is 2 times 0.03, which is 0.06 mole. So 0.06 mole of HCl have been titrated with sodium carbonate. If we found the total amount of HCl that is titrated in the solution, we can find the number of moles of HCl that have been titrated with the sodium bicarbonate. So the total number of moles of HCl in the second solution is 2 moles per decimeter cubic into volume 40 into 10 to the power minus 3 decimeter cube. So the answer will be 0.08 moles. So if you subtract 0.08 with 0.06 mole, then you will have 0.08 minus 0.06, which is 0.02. So 0.02 mole of HCl have been titrated with the sodium bicarbonate. Therefore, number of moles of sodium bicarbonate is also 0.02. Now we have found the number of moles of sodium bicarbonate. So you can, we know the molar mass of the sodium bicarbonate. You can find it. It is 84 grams per mole. So from this you can find the mass of the sodium bicarbonate in the main solution. So there is another thing that I have missed. Actually, this is not the correct sodium bicarbonate moles, because this is the sodium bicarbonate moles in this solution, which is x divided by 2. So the real sodium bicarbonate moles in the main solution is 2 times of this. So when we are considering the mass of the sodium bicarbonate, we have to multiply this value by 2. I will raise this part to find that one. So if you consider the mass of sodium bicarbonate, it is number of moles into molar mass. Number of moles is 0.04 mole, because I said we have to multiply by 2 into 84 grams per mole. So the answer will be 3.36 grams. So if you consider the mass percentage for the sodium bicarbonate, you will have 3.36 grams divided by 9.72 gram multiplied by 100%. So you will get an answer 34.56%. Okay, now let's move on to the 16th question. True statement regarding increasing the rate of a reversible reaction by a catalyst. First one, catalyst increases the rate of the forward reaction only, that's totally false. Because in an equilibrium situation or in a reversible reaction, catalyst will increase the both forward and backward reaction with equal amount. So first statement wrong, second statement wrong, because it said catalyst increases the rate of backward reaction only, that's totally wrong. So the third one, catalyst increases the rate of both forward and backward reaction by the same amount, that is correct. And the fourth one, increasing the rate of forward reaction or the backward reaction depends on the nature of the catalyst and reaction, it's just telling. And the fifth one, even though the catalyst increases the rate of forward and backward reactions, necessarily it cannot be stated it increases by the same amount, that's also wrong. So the answer for the 16th question is third, which is a direct theory point. So let's move on to the 17th question. Carbon reacts with copper oxide at higher temperature. This is used to extract copper solid from copper mines. So this is the reaction. Copper solid reacts with carbon solid, forms two copper solids plus carbon monoxide gas. The standard entropy and enthalpy changes for the above reactions are 165 joules per mole per Kelvin and 58.1 kilojoules per mole respectively. At what temperature does the reactions occur spontaneously? Spontaneously means when the Gibbs free energy is 0. Gibbs free energy is 0 means or less than 0, it is a spontaneous reaction. So we can't consider as the other situations. The only situation we can consider as Gibbs free energy is 0. So the equation is delta H naught minus T delta S naught. So here 0, then standard enthalpy change is 58.1 kilojoule. I just convert the kilojoule into joule. 3 joule per mole minus temperature into 165 joule per mole. So if you consider T becomes equals to 58.1 into 10 to the power 3 joule per mole divided by 165 joule per mole. So the answer you will have 352 Kelvin, which is the second answer. Let's move on to the 18th question. The mole ratio of the magnesium carbonate and calcium carbonate in the carbonate mixture is 5:1. When a known mass of this mixture was heated with the volume of carbon dioxide, the volume of carbon dioxide emitted under the standard temperature and pressure is 13.44 decimeter cubic. What is the heated mass of the mixture? So they are asking what is the heated mass of the mixture. Then you can have that they have given the volume of the carbon dioxide released. So you know there is an equation for the gases. Number of moles of carbon dioxide can be equal to the volume of the carbon dioxide divided by molar volume. So number of moles of carbon dioxide we don't know, we have to find that. So the volume they have given 13.44 decimeter cubic and the molar volume also given, which is 22.4 decimeter cubic. So the answer 0.6 mole. So the number of moles of carbon dioxide released is 0.6 mole, and they have given that the ratio of the magnesium carbonate and the calcium carbonate in the mixture is 5:1. According to the equation, magnesium carbonate converts magnesium oxide plus carbon dioxide. Also, calcium carbonate forms calcium oxide and carbon dioxide. In both situations, magnesium carbonate and carbon dioxide, also the calcium carbonate and carbon dioxide, mole ratio is 1:1. So the same ratio can be represented in this situation to find the number of moles of magnesium carbonate in the solution and calcium carbonate in the solution. As 5:1 ratio, you can directly find the number of moles of magnesium carbonate in the solution is 0.5 mole and the calcium carbonate number of moles is 0.1 mole. So if you did the further equations, that means if you find the masses, so the mass of magnesium carbonate is equals to number of moles into molar mass. So number of moles of magnesium carbonate is 84 grams per mole, while the number of moles of calcium carbonate is 106 grams per mole. Therefore, number of moles 0.5 mole into 84 grams per mole. You will have an answer 42 grams. And if you consider in this situation, mass of calcium carbonate 0.1 mole into 106 grams per mole is equals to 10.6 gram. So if you add both answers, you will have a mass of the mixture as 52.6 gram. So there is no answer which is round off to 53 grams. Other answers are totally different, so the answer is 52 grams. Even without doing this calculations, you can observe other answers have 520 grams such values. Those values can't be taken with this number of moles. So after finding this one, you can directly find the answer is the first one. So you can save the time to do the MCQ questions. So if you see the 19th question, let's see the 19th question. Two immiscible liquids A and B placed in a beaker. The distribution coefficient of solute S in both solvents Kd, solvent E is Kd equals 49. Solute S is more soluble in A more than B. If the solute S is more soluble in A more than B, that means definitely the ratio of Kd should be S, solubility of S in A and solubility of S in B. So the number of moles of S which was mixed with 100 centimeter cubic of B is 1 into 10 to the power minus 4 mole was shaken with the 100 centimeter cubic of A. What is the percentage of the S dissociated in the solvent A? So if you consider the two situations, first, there is 1 into 10 to the power minus 4 mole of S in the B solution. So after adding, and the B solution is 100 centimeter cubic, after adding an A solution of same 100 centimeter cubic, and this is B 100 centimeter cubic, they are asking the mole, they are asking the percentage dissociated to the A solution. So here the number of moles present in this solution is 1 into 10 to the power minus 4 mole minus n, and here should be n. So I considered like this. So we can represent this one to this equation. We have to consider the concentrations. So you can just divide 100 by each. You can just, so that with the equation that can be taken out. So 49 is equals to n divided by 100 centimeter cubic divided by 1 into 10 to the power minus 4 minus n divided by 100 centimeter cubic. So both 100 centimeter cubic can be taken. So 49 into 10 to the power minus 4 minus 49n is equals to n. So 49 into 10 to the power minus 4 is equals to 50n. Therefore, n becomes equals to 0.98 into 10 to the power minus 4 mole. So they are asking the percentage. So if we consider the percentage of dissociation is equals to 0.98 into 10 to the power minus 4 mole divided by 1 into 10 to the power minus 4 mole into 100%. So this is the total number of moles, and this is the number of moles dissociated to the A solution. So if we divide both and multiply by 100%, you can get the percentage value. So the directly percentage value is 98%. So the answer for the 19th question is 5th. And you can consider the 20th question. Which of the following thermochemical process is endothermic? First one, which is potassium, that means it is directly, you can see it is a lattice formation enthalpy. Lattice formation enthalpy is mainly exothermic. Lattice dissociation is the endothermic. Therefore, first one is the exothermic. And the second question, if you see, it is an electron gain energy. Electron gain energy for the oxygen is exothermic, but electron gain energy for the nitrogen, because it is partially filled, it have partially filled atomic orbital, it's in its last valency. Therefore, the third one, that electron gain energy of nitrogen is endothermic. Therefore, the endothermic process is the third one. So the answer is third one. We will see the fourth question also. Fourth question is the dissolution of magnesium 2+ with the water, also you can say hydration. For that one, it is an exothermic reaction, and the fifth one is neutralization. Neutralization also an exothermic reaction. Therefore, answer for the 20th question is third one. So the answer for the 20th question is third one. So if you consider the 21st question, which of the following shows the incorrect product of for the corresponding reactions? So if you consider the first reaction, these reactions are directly given in the resource book. For the first one, the reaction is correct. And the second one, the reaction is wrong, because for carboxylic acid attached to a benzene, we can't use sodium borohydrides to convert it into an alcohol. We have to use lithium aluminium hydride with H plus H2O. We have to use lithium aluminium hydride with H plus H2O to convert a carboxylic acid attached to the benzene into the alcohol group. But sodium borohydride cannot be used. Therefore, the wrong answer is the second one. So, answer for the 21st is the second one. We can also see the other statements, other reactions which are totally correct. Let's consider the 22nd question. The correct energy profile of the following reaction is, so they have given the reaction. So the first step, which A, B, A plus B converts to AB, and the second step is AB plus B converts to AB2. So the first step is fast and the second step is slow. So in these questions, you don't want to need the calculations or anything, and even the enthalpy change, that is just an information you don't want to consider. So in this reaction, you have to take two main points. That is, if there is a fast reaction, the activation energy should be a smaller value, and if there is a slow reaction, the activation energy should be a higher value. So the path of the first step should be a smaller one, and the path of the second step should be a greater one. That is the first point you have to consider. And the second point you have to consider is the enthalpy change is a negative value. The enthalpy change is a negative value means the products should be in a lower positions compared to the reactants. So let's consider the graphs. So if you consider the first graph, all statements that I said, that means the two main statements, that the first step should have a smaller path and the second step should have a higher path, that one is correct, and also the products are below the reactants, so that statement also correct. But if you consider the second graph, the path of the first step is greater than the path of the second step, therefore that is wrong. And if you consider the third graph, the paths are correct, but the product is higher than the reactants. So it will become an endothermic reaction, but it is an exothermic reaction, so that is wrong. So if you consider the fourth one, also same problem, wrong, and the fifth one is totally wrong because there are two steps they have given in one step. So the answer for the 22nd one is the first one. And let's consider the 23rd question. When compound X is subjected to following experiments, the below observations are made. So let's consider the observations and you can directly find the answer. So the first observation, reacts with molten sodium hydroxide and emit a gas. So definitely there should be a hydroxyl group attached to benzene, or separate hydroxyl group should be there. So if you consider the answers, there is a separate hydroxyl group in the second one, and the third one, and the fourth one, and the fifth one. So you can't find with that statement. Let's see the second one. Gives an orange colored precipitate with the Brady region. Two compounds give an orange color precipitate with the Brady region. Those are ketones and aldehydes. So in the second, third, fourth, fifth answers, which have the ketones and aldehyde. Let's see. Second have an aldehyde, and third have an oxalate group, so we can't consider the third one. Fourth have a ketone, and fifth have an aldehyde. So gives a silver mirror with tolerance region, that is the third statement. So definitely gives a silver mirror with tolerance region means it should have a aldehyde group, not a ketone, because ketones can't give this color change for this experiment. Therefore the answer for the 23rd one is the fifth one. Let's see the question 24. You have to do some extra calculations for 24th question. Kinetic data related to the reaction A plus B converts to C is given in the table below. So with the table below, they are asking the rate constant. To find the rate constant, first you have to find the order. So order of the A relative to the reaction, rate of reaction, and order of the B relative to the rate of reaction. Later you can find the rate constant. So if you consider the two situations, equation number 2 and equation number 3, where the B concentration is kept constant, you can find the order of the A respective to the rate of the reaction. So R so we have to find B, M, N, M and N. So if you consider the second and third, the rate of reactions 4 into 10 to the power minus 3 moles per decimeter cubic per second divided by 1.6 into 10 to the power minus 2 moles per decimeter cubic per second equals to 5 into 10 to the power minus 4 moles per decimeter cubic. So in every situation you have to write the unit if you are writing an essay. So I'm not writing the unit for each and every situation because you have more process to do. But when you are writing an essay, definitely you have to write the units for each and every situations. Into 10 to the power minus 5 n. So you can cancel out these two, and if you cancel out these two, this 10 to the power minus 1. So 0.41. So you will have 1 over 4 equals 1 over 2 m. So m becomes equals to 2 in this situation. So if you consider the next situation, there is no any situation where the concentration of A is constant. To find the change of concentration of B affects the rate of reaction. So you can just take two equations where B concentration changes, and using the found order as m equals 2, you can find the order of the B concentration. So let's do here. Let's take the first statement and the second one. I will erase this because there is no space to do that. We have found that m equals 2. So using the equation number 1 and 2, you can get just 5 into 10 to the power minus 4. You have to write the unit moles per decimeter cubic per second. 4 into 10 to the power minus 3 equals to 2.5 into 10 to the power minus 4 divided by 3 into 10 to the So if you consider, you can just cut this one and this one. And then you can cut this one. So 0.5 divided by 4 is equals to 0.5 squared into 3 over 6 n, which is a half, and here you can subtract 0.5. So if you took 0.5 downward, you will have 2. So 1 over 2 becomes equals to 1 over 2n. Therefore, n becomes equals to 1. So after finding the order, you can substitute this one to this equation for any step and find the constant, rate constant. So if I am substituting for the third equation, R is equals to K concentration of A squared B1. So the rate is 1.6 into 10 to the power minus 2 K into 1 into 10 to the power minus 3 squared 6 into 10 to the power minus 5 1.6 into 10 to the power minus 2 equals to K into 6 into 10 to the power minus 11. So K becomes equals to 2.66 into 10 to the power 8 So you have to find the units, but no need because all the units are same in these answers. So you don't want to find the units. You can find the answer and you can get the rate constant. So in each and every situation, I have to write the units, but as this is an MCQ question, I didn't write it, but if you are writing the essay, you have to write the units for each and every question. So let's move on to the 25th question. So the answer for the 24th question is the first one. 25th one. So they are saying there is 0.05 moles per decimeter cubic sodium hydroxide is gradually added to 25 centimeter cubic of 0.05 moles per decimeter cubic HCl solution. Which of the following graphs correctly shows the variation of the conductivity of the solution? Conductivity means the conductivity of the electricity. For an electricity conduction, they need free electrons or the free ions. So if you consider first HCl solution before adding sodium hydroxide solution, the conductivity is really high because there are H plus ions and Cl minus ions. In this initial solution, there are H plus ions and Cl minus ions. When you are adding sodium hydroxide starts to neutralize with HCl and forms compounds which are lack of ions. So when you are adding sodium hydroxide step by step, it will start to neutralize the HCl solution. So the conductivity of the solution decreases because the free ions or the free electrons get decreases. So if you consider the graph of the conductivity and sodium hydroxide volume, until neutralization, conductivity decreases because the ions get decreases. So this is the point of neutralization. After neutralization, you are adding excess sodium hydroxide. Excess sodium hydroxide in the solution will also create the ions, sodium plus ions and hydroxide minus ion. So if you consider those situations, when you are adding excess sodium hydroxide, so the ions of the solution start to increase. When the ions of the solution starts to increase, conductivity will be increased. So the only answer with this graph is the second one. So if you consider the 26th question, consider a reaction in dynamic equilibrium in a closed system at 500 Kelvin. So here N2O4 is converted to NO2, and which is an equilibrium reaction. The equilibrium constant Kc of the above equilibrium at 500 Kelvin is 3. Which of the below statement is correct about the above system? So the first statement, the equilibrium constant Kc of the reaction in the equilibrium at 500 Kelvin is 0.33. So they have said the equilibrium constant of the equilibrium constant of gas converts to NO2 gas is 3. So in the first question, in the first answer, they are asking if this product and reactant interchange, what is the Kc value? When these values are interchanged, Kc value becomes 1 over Kc. Then the value will be 1 over 3. 1 over 3 is equals to 0.33. Therefore, the first statement is totally correct. But when you consider the second statement, the value of the equilibrium constant increases when N2O4 gas added to the equilibrium system at 500 Kelvin. Here temperature is not changed, temperature is constant. When the temperature is constant, equilibrium constant doesn't change. Therefore, even though we are adding extra N2O4 gas, equilibrium constant doesn't change. The rate of forward reaction decreases when the temperature of the system increases. Rate of forward reaction and rate of backward reaction increases equally when the temperature is increased. So no backward or forward reaction decreases when the temperature increases. So that statement also wrong. Fourth one, when carbon dioxide gas added to the system from outside, the equilibrium constant Kc becomes less than 3 at the above temperature. Here temperature doesn't change, so whatever you did, as the temperature is constant, equilibrium constant doesn't change. Fifth one, the K1 over K2 value of the above equilibrium at 700 Kelvin is less than the value of K1 over K2 at 500 Kelvin. That's totally wrong, because when the temperature increases, K value also increases. So equilibrium constant increases when the temperature increases. But they have said it is less than, therefore fifth statement also wrong. So the answer for the 26th question is the first one. Let's consider the 27th one. Which of the following statement is correct about the 3D block elements? Titanium and zinc do not show valency. That's totally wrong. For the first statement, titanium and zinc show valencies. So the 27th question, titanium can show +3 and +4 valencies, while zinc shows +2 valency. So the first one which said that titanium and zinc do not show valency is wrong. Second one, 3D block elements only form acidic and basic oxide. No, they also form neutral oxides. Third one, zinc has the lowest melting point among the transitional elements in the 3D block. First of all, zinc is not a transitional element. It is a non-transitional element. So you don't want to consider it is a melting point greater all over. As zinc is a non-transitional element, they have said as transitional element. That one is also wrong. If you consider the fourth statement, catalytic action by d block elements occur due to the presence of partially filled d orbitals. That is correct. That is directly in the resource book. Fifth one, chromium has the highest oxidation state among the 3D block elements. That's totally wrong. Manganese have the highest oxidation number, which is +7, but chromium have only +6, which is lower than the manganese. So the answer for the 27th question is the fourth one. Fourth one is the correct statement. Twenty-eighth question. Which of the following statements about the two compounds below is incorrect? So first one said, compound A can be named as butane 2-one and compound B can be named as butane. That is correct, because in compound A there is a ketone, and in compound B there is an aldehyde. So the naming is correct. Second one, compound B is a good reducing agent than the compound A. That is also correct, because aldehyde is a good reducing agent than ketone. And when you consider the third one, Fehling solution can be used to identify the above compounds separately. That is correct, because using Fehling solution you can separate the ketones from aldehyde. Fourth one, both of these compounds can be subjected to Clemmensen oxidation, also Clemmensen reduction. Correct. Fifth one, both of these compounds are the examples for the position isomers. That is the false statement. That is wrong. So the answer is fifth one. For 28th, answer is fifth one. Okay, let's move on to the 29th question. X is a metal. It forms an oxide XO. When XO is heated with O2, it forms another oxide X, another oxide of X. 1.44 gram of XO give 1.6 gram of that other oxide of X. What is the molecular formula of the other oxide of X? So that is the question. So if you consider the equation, here XO reacts with O2 and forms another compound. We don't know the values, we will just say XM and ON. So if you consider, definitely the number of moles of X here should be M, then only it can be neutralized reaction. So I didn't write the O2 value. With this value, there will be another separate O2 value, but we don't need that. So they are saying with 1.44 grams of 1.44 gram of XO, you can prepare 1.6 gram of X oxide. So that means if the number of moles of XO is M mole, the number of moles of this new oxide of this compound is 1 mole. You have to consider this value. So now we can compare both moles. So by comparing both moles, so the if you divide the number of moles of XO by M becomes equals to the number of moles of XMON. So let's write the equation. We can find the number of moles of XO using the mass. So it is 1.44 grams divided by, so they have given the relative atomic mass of the X is 56. Therefore, the relative atomic mass of the XO is 72 grams per mole. Therefore, you can divide this by 72 grams per mole into M becomes equals to 1.6 gram divided by, so as the relative atomic mass of X is 56 times M plus 16 times M. So this is the relative molecular mass of this oxide. So from this equation you can find a relationship for M and N. So let's further doing, we can cancel out this as 0.02. So you have 56M plus 16N is equals to 1.6 divided by 0.02 into M. Here, 0.02. So you will have an answer as 56M plus 16N becomes equals to 80M. So if you subtract these M values, 16N becomes equals to 24M. So 2N is equals to 3M. Now there is a relationship for M and N. So if you consider the answers, first, second, third, by substituting N and M, you will have the equal value only in the fourth answer. So therefore, the answer for the 29th question is 4. Only in the fourth answer you will have 2 into 3 becomes equals to 3 into 2, which is 6. So the answer number for the 29th question is 4. Let's move on to the 30th question. Equimolar mixture of two liquids, A and B, acts ideally. The saturated vapor pressure of A and B at a certain temperature are X and Y. In a closed system, containing only an equimolar mixture of A and B. What is the molar fraction of A in the vapor region above the surface of the solution with the equimolar solution? So they have said equimolar solution means the number of moles in the liquid phase of A and B are equal. So they have said that saturated vapor pressure of A is X and saturated vapor pressure of B is Y. So if you consider a system where A and B, so half number of moles is A and the other half number of moles is B. And if you consider they are asking the vapor fraction, that means mole fraction of A in the vapor region, they are asking the mole fraction of A. So according to the Rolle's law, PA, partial pressure of A in the vapor section is equals to XA into P naught A, which is the value half into, and the partial pressure of P naught A is X. Therefore, partial pressure of PA is X over 2. And if you consider the partial pressure of PB is equals to XB into P naught B. So it is half Y. So if you consider the total pressure total is equals to partial pressure of A plus partial pressure of B. It is X over 2 plus Y over 2, which is X plus Y divided by 2. So they are asking the mole fraction of A in the vapor region. So if you are considering the molar fraction of A, you can simply state as the partial pressure of A divided by partial pressure, total pressure. Because if you divide both, you will have that nRT over V. The V is constant, volume is constant, R is constant, temperature is constant. So all the value will be divided and only the number of moles will be remain. So the molar fraction can be taken from this partial pressure of A divided by total pressure. So partial pressure of A we have found, which is X divided by 2, and the total pressure is X plus Y divided by 2. So 2 cancel out, X divided by X plus Y. So the answer is third one. So this is the molar fraction of the A in the vapor phase. That is the third answer. Let's move on to the 31st question. The rate of the reaction A converts the products is expressed as rate is equals to 1 over T, and then 1 over T is equals to K-A-N. So here T, K and N represents the reaction time, rate constant and the order of the reaction with respect to A respectively. The reaction is carried out at constant temperature. The following graph shows the kinetic of A according to the equation given above. Which of the following statements are true? So in this graph, log value of 1 over T doesn't change even though the concentration of A changes. So it means it doesn't, rate of the reaction doesn't depend on the concentration of the reactant. Therefore, the order of the concentration of A will be 0. Let's see the statements. The above reaction is a first order reaction. That is wrong. A constant temperature, at constant temperature, the rate constant can be determined from the intercept of the graph. That is wrong because these are log values, so you can't find the intercept of the graph as the rate constant. So C statement, at constant temperature, even if the concentration is changed, the initial rate of the reaction remains unchanged. That is true because even though concentration is changed continuously, the rate of the reaction is constant. At constant temperature, the unit of the rate constant is S minus 1. It is given as time. Rate of the reaction is given as 1 over T. Then rate constant have a unit of s minus 1. So the C correct, D correct. Therefore, the answer is third one. Let's move on to the 32nd question. The incorrect statements among the following regarding the reaction of the compound this with HBr, they are asking. So when HBr reacted with this compound, the most stable carbocation formed is so this is the most stable carbocation that is formed. And then the bromine minus will come and attack here. So I didn't draw the mechanism, so you will understand. This is the most stable carbocation and this is the intermediate compound. And when the bromine attack, the major compound formed is so in the first statement they are saying the major product formed is, that is wrong. The major product formed in this situation is this one. Therefore A is wrong. Let's see B. The most stable intermediate ion formed in the reaction mechanism is, the most stable carbocation is this one, but the statement gives another molecule, therefore it is wrong. This is an electrophilic addition reaction. Yes, correct. It is an electrophilic addition reaction because double bond is rich in electrons. So the one who is coming to attack the double bond should be an electron deficit, which is an electrophile. Therefore, electrophilic addition reaction. Statement D. The major product formed exhibits enantiomers. Yes, it shows optical isomers. So where there is a benzene compound, hydrogen compound and bromo compound and another compound. So therefore, D statement is correct. They are asking the incorrect statement, which is A and B. So the answer is first one. Let's see the 33rd question. Which of the following reactions is or are correct? If you consider the first reaction, it is totally wrong because when Grignard region is attacked with an aldehyde, you will have a compound which is a combination of two compounds, but they have given a reduction. Therefore, statement A is false. Statement B, when HBr is connected to a terminal alkyne group, so the reaction and the product is correct. Therefore, B statement is correct. And the statement C, when H3Br is reacted with a terminal alkyne, you will have a compound reaction. So it is an addition reaction. So the C statement also correct. When you consider the statement D is wrong because they have written actually Cu2 plus is wrong. It should be Cu plus. Because of this error, D statement is wrong. Let's move on to the 34th question. Which of the following statements are incorrect regarding ammonia and its salts? So if you consider the 34th question, A is correct because ammonium salts react with bases releasing ammonia gases. When you consider the strong bases, ammonium salts react with strong bases to form ammonia gas and a neutral compound. But when you compare the weak bases, ammonium salt doesn't form ammonia gas with weak bases. But they haven't said always, they say just it is a statement, ammonium salts react with bases releasing ammonia gas. Therefore, statement A is correct. Statement B is wrong because blue litmus paper converts to red litmus paper when an acid is mixed with it. But ammonia gas is a gaseous gas, therefore the B statement is wrong. When you consider the C, all ammonium salt releases ammonia gas upon thermal decomposition, wrong, because NH4, NO2, these compounds doesn't release ammonia gas under the decomposition. So if you consider the D, the reaction of ammonia gas with excess chlorine produces NCl3, that is totally correct. With excess chlorine, the products are NCl3 and HCl. With excess ammonia, products are N2 plus NH4Cl. Therefore, D statement is correct. They are asking the incorrect statement. The answer is second one. Let's move on to the 35th question. The Gibbs free energy of the system in dynamic equilibrium at 298 Kelvin inside a closed vessel is shown below in the graph. Which of the following statements are correct regarding the following graph? Statement A, the equilibrium point is given by X and at that instant Gibbs free energy is 0, that is correct. Statement B, if the equilibrium constant is K, dynamic equilibrium is greater than 1. 35th, A is correct, B is also correct, and C, when the reaction begins and moves forward while negative Gibbs free energy decreases, QC gradually decreases, that is wrong. At dynamic equilibrium value of K is less than 1, that is wrong because it is greater than 1. So the answer is answer number 1. Thirty-sixth question. The correct statements from the following are: at the end of the 24 hours of, there is a small mistake, please correct it as 24 hours of sweet toddy fermentation. At the end of the 24 hours of sweet toddy fermentation, the mixture contains a definite percentage of sugar, ethanol, and acetic acid, that is correct. Fractional distillation is used to separate two components of a mixture that are immiscible, wrong, miscible with each other but have different boiling point. Here the wrong one is immiscible. Actually the answer should be miscible solutes. So the B statement is false. When you consider the C, in the fermentation of fruits and raw rice aldehydes and ketones are formed. That is correct. Aldehydes and ketones are formed. Biodiesel is produced industrially by hydration of ethylene. Correct. So if you consider the 37th question, A. Production of gases like hydrogen sulfide in anaerobic conditions contributes to the eutrophication of the reservoirs. That is correct. That is directly stated in the resource book. The major limiting factor of algal growth is nitrate. That is wrong. A is correct. B is wrong. Actually, it is phosphate. And C. Some heavy metal ions do not contribute to any biological activity. That is correct. Directly stated in the resource book. Heavy metals occur as hydrated ions and complex compounds in natural water. That statement also correct. Therefore, the answer is fifth one. Thirty-eighth question. L, M, and N are three metals. When L is kept in a solution, M2 plus of M2 plus, L didn't oxidate, but when N is kept in the solution of M2 plus, N oxidized to N2 plus. So, according to this statement, you can have a conclusion that when you compare these three metals, M, L, M, and N, when L and M are in the same solution, L is not oxidized. That means it is reduced. If it is reducing means it has the ability to reduce more than M. Therefore, the electrode potential of L should have a greater plus nature than M. So here N have been reduced compared to M. N have been oxidized compared to M. That means M have a higher reducing nature than N. Therefore, the plus nature of M should be greater than N. So you can have a small conclusion according to this statement. And they have given some electrode potentials of each metals. So let's see the answers and we can find. So the statement A, copper, zinc, and magnesium. So the electrode potential of the copper is plus 0.34 and the zinc minus 0.76 and the magnesium minus 2.36. Therefore, A is correct. Let's see B. Magnesium, lead, and zinc. Magnesium minus 2.36, lead minus 0.13 volt, and zinc minus 0.76 volt. That is totally wrong because actually these have a highest negative nature, but this element should have highest positive nature according to this order. Let's see the C statement. Tin, zinc, and copper. So it is minus 1.14 volt and zinc is minus 0.76 volt and the copper is plus 0.34 volt. That is also wrong. The order is incorrect. But when you consider the D statement, which is copper, lead, and tin, copper have plus 0.34 volt, and if you consider the lead have minus 0.13 volt, and the tin have minus 1.14 volt. Therefore, this statement also have the correct way of increasing negative or decreasing positive. Therefore, the D statement also correct. A and D are correct. Therefore, the answer is fourth one. Thirty-ninth question. Which of the following statements or statements are correct regarding D block elements? 39th, let's see. Ferrous hydroxide and manganese hydroxide change their color when exposed to air. That is correct. Both change their color into brown when they exposed to air. And when you consider the second statement, only zinc form colorless complexes in the D block, that is totally wrong, because there are scandium and more compounds that can form colorless compounds. Let's see. Titanium and chromium both show +5 oxidation state. That is wrong. Titanium shows +3 and +4 oxidation state, while chromium shows +2, +3 and +6 oxidation state mainly. No one shows +5 oxidation state. D statement, chromium reacts with ammonia but does not react with excess ammonia. That is correct. It reacts with ammonia but does not react with excess ammonia. Therefore, the answer is 4th. Let's see the 14th question. Which of the following statement or statements are correct regarding the acid rains? NO2 gas, O2 gas reacted and forms N2O gas, and O2 gas reacts together to form NO2 gas, can be considered as a step in the formation of acid rains from NOx. That's correct statement. And when you consider the statement B, calcium hydroxide can be used to minimize the release of sulfur dioxide gas into the atmosphere. That is wrong. So the statement A is correct, statement B is wrong. Statement C, the NO gas released from the vehicle emissions contributes to the acid rain formation. That is wrong. NO2 and SO2 strongly contribute to the formation of acid rains, while CO2 contributes to a lesser extent. That is totally correct. Therefore, the answer is 4th one. Let's move on to the 41st question. The two NO bonds of HNO2 have the same length. That is wrong. If you draw the bonds N if you consider the HNO2 bond, here NO bond is a double bond, while in this situation NO bond is a single bond. Therefore, the two NO bonds of HNO2 have the same length is wrong. But if you consider the hybridized molecule, that the standard hybridized molecule of HNO2, then that statement is correct. But for the normal HNO2 molecule, NO bonds for both situations are different. So, first statement is wrong. Second statement, two stable resonance structures can be drawn for HNO2. That is wrong. We can't draw stable two resonance structures. 42nd question. All meta-directors deactivate the benzene ring. That is correct, because all meta-directors are deactivators. But if you consider the second statement, all deactivators are meta-directors. That is wrong, because there are some halides, halobenzene, like here. This is a orthopara director. It is an orthopara director group, but it also undergoes deactivator. So this is a deactivator, but it is an orthopara director. So the statement which says all the deactivators are meta directors, that is wrong. So let's consider the 40. So the answer for the first one is 5th, as both is wrong, and the second one is 3rd, as the first statement is correct and the other one is wrong. 43rd. A solution of acetone and CHCl3 makes a non-ideal mixture with a negative deviation from Rolle's law, that is correct. When acetone and CHCl3 are mixed, hydrogen bonds are formed in between its molecules, it is correct. Because of hydrogen bonds are formed in between these molecules, the ability to release a molecule to vapor phase is less. Therefore, the Rolle's law will have a negative deviation. So both statements are correct. And the reason for the first statement is the second statement. Therefore, the answer is first one. 44th question. The bond energy of F2 gas is greater than that of Cl2 gas. That is wrong. So normally we have that, if you see the second statement, you will understand when the bond length in between atoms decreases, its bond energy increases. That's true. When the bond length decreases, so if there are two more elements, two molecules, if the bond length decreases, its bond energy increases. So there will be a question, F2 have a less bond length compared to Cl2. Why? F2 have a less bond energy than Cl2. Actually, according to this statement, as the bond length is decreased, there should be a less energy. There should be a high energy for F2 compared to the Cl2. So the bond strength of the F2 should be stronger. But in this situation, as F2 are more closer, their lone pairs start to repel each other. Due to this lone pair repulsion, the bond energy of this molecule is less and the bond strength also less. But chlorine have a separate gap which doesn't affect the lone pair repulsion. Therefore, the bond energy of the chlorine is greater than the fluorine molecule. So the answer for the 44th question is 4th one. Let's move on to the 45th question. The reaction of benzene with alkyl halides in the presence of anhydrous AlCl3 is an electrophilic addition reaction? No, it is an electrophilic substitution reaction. Therefore, that statement is false. During the first step of the reaction between primary alkyl halides and benzenes, R plus electrophile is formed. That is wrong. Because it has a single step reaction, therefore no ions are formed. So this statement, both are wrong, therefore the answer is 5th. 46th question. In galvanic cell, the anode is negatively charged, correct. Because in the galvanic cell, anode is negatively charged. So I don't need to draw the cell because it's a direct statement. The galvanic cell, an oxidation reaction occurs at the anode, that is correct. Always, if there is an oxidation reaction, that terminal is called as anode, and if there is a reduction reaction, that terminal is called as cathode. Therefore, the statement is correct. But both of them are, as both of them are related, the answer is first one. So let's see the 47th question. Always the compression of real gas is harder than the compression of ideal gas. Wrong, because ideal gas are they are situated far apart, so there are much gaps and the volume of the ideal gases are really low. So the compression of ideal gases is easier than the real gases. So the first statement is wrong. So if you consider the second statement, real gas molecules are larger than the ideal gas molecules, that is correct. Because real gas molecules have a separate volume, but ideal gas molecules are point masses. So the answer is fourth. 48th question. When oxalic acid is added to an equilibrium system of iron thiocyanate, the red color of the system decreases. That is correct, because thiocyanate is FeSCN 2+, which gives a blood red color. So when we are adding oxalate ions, Fe3+, which is in this compound, will be reacted with oxalate to form FeC2O4 3 minus ion. When this reaction continues, F3+ in the solution will be decreased, so thiocyanate number will be decreased, therefore the blood red color decreases. The statement which says that the red color of the system decreases is the correct statement. And the second statement, oxalic acid reacts with Fe3+ ion, forming the stable complex of this compound. So they have given the correct compound, and I have even written the equation. So obviously this statement is correct. Both of them are related, therefore the answer is first one. Let's consider the 49th question. Temporary hardness of water is given is when the concentration of carbonate and bicarbonate is higher than the concentration of multivalent metal cations. That is true. Mainly the hardness of water depends on the concentration of carbonates and bicarbonate ions. Boiling water can prevent temporary hardness. That is also true. But both of them are not related. Therefore, the answer is second one. So the 50th question, which is the last question. Glycerin is not completely removed from soap. That is correct. Because when forming soap, triglyceride reacts with sodium hydroxide to form glycerol, which is the glycerin plus soap. So actually glycerol is not fully removed from the soap. Therefore this is very important, because presence of the glycerin or the glycerol makes the dissolves in water. It makes the solubility of water. Also the soft and smoothness of the soap is maintained by the glycerin. Therefore, the second statement also true, which says soft and smoothness of the soap is maintained by the glycerin. So both statements are correct and both statements are related. Therefore, the answer is first one. So that's it, the chemistry MCQ discussion. I hope everyone have done the questions, and I think what I have discussed, you can understand that. So thank you.